We're starting chapter 2 in the geometry textbook. Chapter 2, you can see, is concerned with parallel lines. Everything we study in this chapter is going to have some relationship to parallel lines. And so before we get started with this chapter, I wanted to make this video to review what we currently understand to be the meaning of what exactly are parallel lines. What does that mean exactly? Now, in chapter 1, we already did talk about this. However, as I like to do in all of the different playlists on this channel, and actually it looks like the writers of this textbook have a similar approach, because we were given the official definition of parallel lines in chapter 1, and in this opening section of chapter 2, they actually repeat the same definition here. So I'm not shy at all about repeating information more than once in different videos. Because when you're trying to absorb information, trying to learn and retain information, repetition can be really helpful. So if you're watching one of these videos and a topic comes up and you feel like, well, I've already heard that topic, just watch it again. Watch it again like you've never heard that topic before. Think about it in your head. Imagine it in your head from another perspective. When it comes to trying to learn something or to acquire knowledge, repetition is helpful. Okay, so let's take a look at the definition. Parallel lines are lines in the same plane that do not intersect. Okay, so they're lines, first of all, two or more lines. So a line, we know, it extends infinitely in both of its respective directions. It has an infinite length. Okay, then they're in the same plane and they don't intersect. So lines that are in the same plane and don't intersect. Okay, let's make sure we understand this. So, okay, geometry takes place in 3D space, all of geometry. So let's draw 3D space here. So you commonly hear the phrase that if you have two lines, that constrains a plane. Two lines make a plane. Well, that statement, as it is not universally true. Most of the time it's true, but it's not universally true. A statement that would be universally true is that two intersecting lines always constrain a plane, make a unique plane. So if we draw one line randomly oriented here and another line randomly oriented here, okay, they intersect, then every time 100%, two lines that intersect like this, as long as it's not the same line, they're not on top of one another, are going to create a unique, well, they constrain a unique plane in 3D space. There's only one plane, one unique plane, that in that plane it contained is the entirety of both of these lines. They're infinite lengths. Okay, and I'm trying to make this like this randomly oriented, so this plane here you could think of that as your computer screen if you were looking straight down at the plane, right? Okay, so now what are the other scenarios that can happen when you have with two lines in 3D space? Well, okay, there's two scenarios. They either intersect or they don't, right? And we just talked about if they intersect, as long as they're not the same line on top of one another, if they intersect, then there's going to be one unique plane that contains both of those lines. So, but what about if they don't intersect? Well, in that case, there's two scenarios. The first scenario is the case where you've got two lines. Okay, they don't intersect, but it still is the case that there is one unique plane that contains both of these lines. One and only one unique plane that contains the entirety of both of these lines. Okay, but they never intersect throughout their infinite length. This is the meaning of two lines that are parallel, or two or more lines that are parallel. So we could have a third line in here. Then all three of these lines are parallel, or I mean, you could have a separate line over here that still, like this line and this line might be parallel. They're contained in different planes though, right? But they're still parallel. Okay, that's what parallel means. That's the meaning of when it says here that they're in the same plane. That's what's being referred to there. So, but why do they need to say in the same plane? I mean, is there another scenario where two lines in 3D space wouldn't intersect, but they're not in the same plane? Yes, that's what skew lines are. So we have a line here, and you might have a line maybe coming like up and to the right. Those lines, they never intersect, but you can't find one unique plane that contains both of those lines. Yeah, you could get one plane that contains the entirety of this line here and that intersects the other line, but it doesn't contain the entirety of the other line. So you think it's so like you can think about it from like a rectangular prism. These two lines don't intersect, right, for their infinite length, but these aren't parallel. They're skewed because you can't. This plane contains this entire line, but it only intersects this other line. Now coming back to okay, we've got here's two parallel lines, and there's the plane that contains these two lines. But then there's a third line out here. Okay. But so, okay, this is line L. Let's say this is line M. This is line N. Okay. Well, so it's still the case you can say, so lines L and M are parallel, but you can say lines L and N are parallel because they're not intersecting and there's a unique plane that contains both of the lines. Right. And it's the same idea with lines M and N. Those two you can say are parallel. There's unique, they don't intersect. There's a unique plane that contains both of them. But what about these three lines together? Are lines L, M, and N parallel? Well, no. You would, the way you look at it is, it's like, okay, if you have two lines that are parallel, then there's this unique plane that contains them, okay? Then you could think about, you could rotate the 3D space here to make it flat with your computer screen, and then you would see these two lines, lines L and M. You would see them as being parallel in that sense, and their common plane would be flat with your computer screen. But then I guess, yeah, I mean, you could technically still see N, but it wouldn't be, it would be kind of in the back. Like you wouldn't be looking at 3D space anymore, is what I'm saying. So you wouldn't include N. Because if you included N in there, then it would imply that N is like at the same spatial location into and out of the computer screen. And that's not true. So in that sense, you don't say that all three of these lines are parallel together. I guess you could say, like, as a group, N is skewed from both L and M at the same time. However, if you're just looking at L and N, those two aren't skewed. If you're just looking at M and N, those two together aren't skewed, but as a group, L and M are skewed from N, and N is skewed from L and M. It needs to be the case that, like, but if you had, line P here, then if you made that plane here, plane A, flat with the computer screen, then you would see line P. So all three of those are parallel together. But if there's skewness between lines, then there's no plane that you can view that make it flat with the computer screen, and you can see the entirety of the lines you're interested in. So they're not that means they're not parallel. That's the idea. So okay, that's what we mean by lines being parallel. So now we have that solid understanding as we go through this chapter.